Okay, the next example we're going to be looking at for the rate law determination is this set of data here. Okay, and so I'm going to do this one a little bit differently because we have 4 different experiments even though we only have 2 compounds. All right, so again, the generic rate law, which I can write up here, is rate is equal to K times B, the concentration of BF3 to the M times NH3 to the N. Okay, so I have 2 different compounds here. Now, again, the hardest part of this is probably to find the selection of which compounds am I going to be using. Okay, so remember that the criteria is that the one I'm interested in, so when I'm working for M, or you can put it as for BF3, either way. Okay, if I look at all the combinations that are different, okay, I have 1 and 3. I have 1 and 4. I have 2 and 3. So I start at the top and I go down. I have 2 and 4. And I have 3 and 4. These are also different. Okay. Now I go back and look because the second criteria is going to limit this down to 1. Okay. The second criteria is that the one that I'm not interested in, which is the NH3 for this one, has to be the same. So if I look at 1 and 3, are these 2 values, this one and this one, are they the same? So looking here, no. So I cross this one out. That one does not fit the second criteria. It has to fit both first and second criteria. If I look at 1 and 4, do those fit the same criteria? No. Those are not the same. If I look at 2 and 3, are those values the same? No. So it does not fit this criteria. If I look at 2 and 4, are these 2 values the same? No. So cross this out. And if I look at 3 and 4, are those 2 the same? And yes, those 2 are the same. So this is the one that I'm going to use for my determination of M. So that means that and then I want, of these 2, which one's the highest concentration, which is 0.350. So it's going to be BF3 for experiment 3 over BF3 for experiment 4 is going to be the rate for experiment 3. Again, these 2 numbers have to be the same, divided by the rate for experiment 4. So this is the same as that one. This one is raised to the M. So now I plug in my numbers. So I have 0.350 divided by 0.175 to the M is 0.1666 divided by 0.417. Okay. So when I divide these two, 0.350 divided by 0.175, I get 2, and that's to the M. When I divide 0.1666 divided by 0.0417, I get 4. So what power is, again, this? And M is not always 2. It just so happens that these 2 examples, they are. I do want to point out this time, however, that you notice the coefficient is not 2. So it does not have to do anything with the coefficient. Okay. Now for N, let me switch colors so that I don't get mixed up here. Okay. So for N, all right, I need to erase all this. Okay. All right, so now I'm interested in this one. Okay, so what are my combinations that I have here? Okay, and again, I start at the top. So 1 and 2 are different. 1 and 3 are different. 1 and 4 are different. Okay. Once I get all the ones from 1, I go down to 2. So 2 and 3 are different, and 2 and 4 are different. But 3 and 4 are not different. Okay. So let me write these down. I had 1 and 2, 1 and 3, 1 and 4, 2 and 3, and 2 and 4. Okay. So now let's start looking, because again, the other part is, are they the same over here? Okay. So when I look at 1 and 2, are these the same? Yes. Okay. So I'm going to leave that one. Okay. There could be more than one. All right. 1 and 3. Are these the same? No. So this does not work. 1 and 4. Are those the same? No. So I cross that out. 2 and 3. Are those the same? No. So I cross that one out. 2 and 4. Are they the same? No. So I cross that out. So the only one that worked was 1 and 2. So now I come back over here, and I'm looking at 1 and 2. I want the highest concentration on top. So NH3 for experiment 1 over NH3 for experiment 2 to the N is equal to the rate for experiment 1 over the rate for experiment 2. So now I start plugging in my numbers. I have 0.250 over 0.125, and that's to the N. I take the 0.2130 divided by 0.1065. When I do 0.25 divided by 0.125, I get 2. And 0.2130 divided by 0.1065, I get 2. So what power is N? N is equal to 1. Oops. I don't know why that erased. Okay. No, they don't always come out to be 2 and 1. It just so happens that's the example. So my rate law, so it usually says determine the rate law. So students do all that work, but they forget to write the simple statement that rate is equal to K times BF3 squared times NH3. Right? Usually it also says obtain K, so K is going to be the rate divided by BF3 concentration squared times concentration of NH3. So for the first K, K1, it's going to be 0.2130 divided by 0.250 squared divided by 0.250, and I got 13.63. Okay, I don't have room to write these all out, but I did the same thing. K2, this value becomes 0.1065. This stays 0.250 squared, and this becomes 0.125. And when I do that, I also get 13.63. K3, same process, gave me 13.6. And K4 gave me 13.62. The average K is the 13.63 plus 13.63 plus 13.6 plus 13.62 divided by 4. So that is equal to 13.62. Okay. So that's a second example of how to determine the rate law and the rate constant for data that is given to you. There will be one more example of this in the next video.